Okay, so today's lesson is Objective 7. We are going to simplify radicals using the nth root. So I'm going to tell you right now, normally we've been looking at square roots, but today we're looking at the nth root, which means n could be anything. We're going to look at the cube roots, square roots, fourth roots, fifth roots, sixth roots, seventh roots. We're going to look at roots of all different numbers. Okay? Any questions on that? And we're just going to focus today on simplifying. I'm going to do this lesson in two parts. We're going to first look at just basic simplifying when everything is perfect, and then we'll do a little bit of practice, and then we'll come back to it and look at things that aren't perfect and what do we do about that. Okay, look out. So we're going to do this in part 1, part 2. All right, so let's look at plus or minus the square root of 16y to the 4th. First of all, I'm going to tell you for today, I'm going to introduce to you the plus and minus. Plus and minus just means the answer could be positive or it could be negative. What's the square root of 16? 4. Do you agree that that could be positive? 4 times 4, positive 4 times positive 4 is 16, positive 16, right? Or you could be negative 4 times negative 4. Could be positive 16, right? I'm going to tell you a story really quickly. So a couple years ago, I was running, and I went up to Roanoke and did the color run. Y'all have ever been in a color run before? And so it was really cold. It was springtime, and that's where, you run through and they splash all the color on you and stuff like that. Anyway, so in the beginning of the day, there was a DJ out there, and he was like trying to, it's freezing. So, and there's like 10,000 people there. And so he was like saying all this crazy stuff, and he was like, like, how are you today? Oh, you over there, you in the red hat, blah, blah, blah. And he was just talking to people and saying like crazy things, and then asking silly questions. And he said, what's the square root of 9? And 10,000 people went, 3! What did Miss Corns do? Plus or minus 3. And everybody around me, because we're like squished in this little confined area, the people that are getting ready to run because it's the start of the race. And everybody looks around and like, who's this crazy person? I said, I'm sorry, I teach math. It could be positive 3 or it could be negative 3 plus or minus 3. So it's not really 3. And they're all like, you nerd, dork, like they gave me the strangest look. So I want you to remember that, like technically when you have an even root, what's the square root of 16? It could actually be positive 4 or negative 4. And that's where we get the plus or minus from. Okay, that's where we get the plus or minus from. So I'm going to tell you today, for any sign that's out there today, if it confuses you for today, just bring it down for today. Okay? And we'll get into more plus or minus and what that means as we move on throughout the semester. Okay? Now this one's pretty simple because we've already talked about this, but what's the square root of y to the 4th? Y to the 2nd. Yeah, very good. Y squared. But we looked at that a little bit with our cubes last week. Like we looked at y to the 6th and y to the 9th and things like that. I told you if you struggled with knowing those, what was the little key? If you don't know what the square root of y to the 4th is, you can always divide it by the root. You can divide by 2. What if it's a cube root? You can divide it by 3. What if it's a 4th root? You can divide it by 4. What if it's a 5th root? You can divide it by 5. Okay? So the answer here would be plus or minus 4 times y squared. Are we still looking at a square root? Yes. How do we know this is a square root and not a cube root? I agree. There's no number. There's no index number right there. And when there is no number, it is understood to be a square root. Okay, so this is a square root. Otherwise, it will have a 3 or a 4 or a 5 telling you which root it is. Okay? So, what did I tell you to do with the negative for today? Just bring him down, okay? And so, I'm going to tell you, this is like a base. Anybody remember what I say about bases? Base stay same? Base stay same. So, what we're going to do is the quantity of x squared minus 6 will stay the same. But what we're going to do to take the square root of this to the 8th power is simply divide the exponent by what? 2. Why 2? Because it's a square root. So this would be 4. It'd be negative times the quantity of x squared minus 6 to the 4th power. Yes? Any questions on that? That's the answer. We're just dividing the exponent by the root. Okay? Now, we'll tell you, like, what if I don't know, put a 9 in front there? Would I need to actually take the square root of 9? Yes, because 9's on the outside. So hint, 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 just for a problem that's coming later with our practice work. If there is a number on the outside, you need to take the square root of that, okay, which would be 3, and it would have a 3 on the outside, okay, but whatever's on the inside, you can leave and just divide the exponent by the root. Have no fear. What root are we looking at this time? Yeah, this is a 5th root. So what we're going to do first things first is I'm going to see, is 243 a perfect 5th root? Do we know how to find the 5th root in our calculator, by the way? I want everybody to hop their calculators out. Everybody hop your calculators out. All right, I want you to go to the math option. Math 4 gives us our cube root. Everybody agree? Math 4 gives us our cube root. But Math 5 gives us our x root. What's the x root? It means it can be x could be anything, right? So there's where you can get whatever root you want. So here's the thing. Everybody go with me. To get the 5th root, I want everybody to hit the number 5 first. Hit 5. Just plain 5, because that's 5th root. 5, and then I want you to hit math, and then I want you to hit choice 5, the x root. Okay? So, and that should give you the 5th root. Let me know if you didn't get it. Hit 5, and then math 5, and then put in 243. So my question is 243 a perfect 5th root? Yes. So what's the 5th root of 243? 3. What does that mean, 3 is a perfect 5th? That means 3 to the 5th power is 243. 3 times 3 times 3 times 3 times 3. 5 times is 243. Okay? How about a to the 20th? We can divide it by 5. Why am I dividing by 5 this time? Because it's the 5th root. So it'll be a to the 4th. I agree. Okay, and then this will become b to the 5th. Any questions about that? And there's your answer. So the 5th root of 243, a to the 20th, b to the 25th, is 3, a to the 4th, b to the 5th. Someone said earlier, should I put the plus and minus on that? Like, could that be plus or minus? The plus and minus thing only works with even roots. Square roots, 4th roots, 6th roots, do you see what I'm saying? Like, if I have something to the 4th power, 2 times 2 times 2 times 2, positive would be a positive 16. Or negative 2 times negative 2 times negative 2 times negative 2 would be a positive 16 to the 4th power. Does that make sense? So that only works with like squares and 4s and 6s. So to the 5th root, this one can be positive or negative. So That doesn't work with odd roots. Just a little note. So what do you think about the square root of 16 x to the 4th y to the 8th? I hear 4 x squared y to the 4th. Any questions? Square root of 16 is 4. And someone said, would that be plus or minus 4? What's the square root of 16? Yeah, if you want to put a plus or minus and be technical about it, it technically is a positive or a negative 4. It could be either. But for today, like, you know, some of the ones out of our textbook, they have the plus and minus in front, and some of them don't. So if it doesn't, you could just leave it plain for today. Okay, I just kind of wanted to introduce that to you because you're going to see it on some of your practice problems, and I knew people would say, what's this mean? So either or, okay? We divide this by 2 because it's a square root, and we divide this by 2 because it's a square root. Any questions on that? So what do we think about the square root of 36 x to the 10th? So plus or minus 6x to the 5th because we're dividing it by 2. Anybody want to ask a question? Like, what do we do when it's not perfectly divisible? Like, what if that was x to the 11th? What do we do? That's what we're going to do in part 2. Does that make sense? Part 1, everything's going to end up being perfect and everything is divisible. Part 2, we're going to look at what happens when it doesn't evenly divide. What do we think? Negative y plus 7, just like this. Can we address something really quickly just to make sure? Is this the same thing as this? No, what does this technically mean? Minus 7, good. Yeah, that is not that. Okay, so make sure you do include the parentheses and the quantity around it, because it's not the same thing when you don't put it. Okay, to the what? Y8th. But the square root of 16 is 4. We're dividing by the root, so it would be to the 8th. Very good. Any questions? All right, so that's part 1. I want you to try these 6 problems really quickly. Let's just make sure you got this before we move on to part 2. All right, so we are picking up on part 2. And so what we're going to look at now, everything in part 1 was perfect. Like you could just take the square root of 16. But let's look at this. What's the square root of 32? There is one, but what is it? 5.6165 something. It's a decimal. So we want to simplify this radical. So let me take you old school for like 2 seconds. Let's throwback Thursday. Let's throw back. Yeah, close enough. We're 1 day off. Let's simplify a fraction. So when I say simplify a fraction, does that mean I want you to take it to a decimal? No, that means I want you to leave it in fraction form, but make it smaller, simpler. So that would become 1/2. So when I say simplify a radical, I do not want you to put it in and get the decimal. Do you understand that? I want you to leave it in radical form, but break it down into smaller numbers. Does that make sense? So when 32 is broken down, and there are multiple ways to do this, but where we're going to have square roots and cube roots and fourth roots and fifth roots, I think this is the easiest way to do it, is we're going to break it down with a factor tree. Okay, so you can break this down however you want to. So what would 32 break down into? I hear 16 and 2. Could you do 4 and 8? Sure, however you want to. So 16 would break down into 4 and 4. And then 4 could break down into 2 and 2. And I would recommend that you circle them as you're done with them, because if not, you're going to miss a piece, especially when they get much bigger. Okay? So what we're going to do is we're going to write 2 times 2 times 2 times 2 times 2. 5 of them underneath the radical. Tell me about x to the 8th. Is it perfect? What would we divide it by? 2. So couldn't that divide by 2? Yeah, so I'm just going to leave him x to the 8th for now. All right, so at this point in time, if it is a square root, we will circle groups of 2. If it is a cube root, we will circle groups of 3. If it's a fourth root, we will circle groups of 4. Do you understand what I'm saying? Fifth root, groups of 5. Sixth root, groups of 6. So we're circling groups of 2. How many groups of 2 can I circle here? I can circle 1, 2. Okay, so this is one set of 2s, so that comes out as a 2. You don't bring both of them out, you just bring one. Does that make sense? Because you take the square root of it. And then you can take this other pair out as another 2. Everybody with me so far? And I can take the x to the 8th out by dividing it by the root, which would be x to the 4th. What would be left underneath? A 2. And what are you going to do? If I take 2 sets of 2 out, what do I do with those 2 2's? You times them. And so you will have 4x to the 4th times the square root of 2. Okay. How many halfway followed with me on that? Halfway? How many all the way followed me? Okay, good. So let's look at another one, because I think it's going to take you a couple to get the idea of it. All right, so the first thing that I would check is 16 a perfect fourth root? Check it. Put in 4, then go math 5, the x root, and then put in 16. It is. It's 2. It's perfect. So my question is, if it's perfect, do we need to break it apart? Right. You don't want to break it apart. So at this point in time, I'm not going to take this out as a 2 yet. Okay, I'm going to look at everything I got. Let's look at a to the 24th. Can it divide by 4? Why would I divide by 4 in the first place? Because it's a fourth root. It has an index of 4. Yeah, it's a fourth root. So is that one perfect? Yes, so I'm going to leave him alone. But let's look at b to the 13th. Can it divide by 4? No. So what we're going to have to do is we're going to have to break it apart into something times something that could be divisible by 4. So, and we want the biggest. Tell me, what's the biggest number that's close to 13 that can be divided by 4? I hear 12. Everybody agree 12? So I'm going to break this down into b to the 12th times what? What's left over? B. A b to the first. Does that make sense? Okay. So, and someone said, but Miss Corns, why didn't the 16 come out? Well, it is going to come out, but it's going to come out in a minute. Here's the thing. I don't want to start taking half of my stuff out now, leave half of the stuff on the inside, and then on the next step, take another half of the stuff. Like, all I did on this first step is, if they were perfect, I brought them down. Okay. And if they are not perfect, like the b to the 13th, I broke it apart into something times something that was perfect. Okay, so now let's circle what we can take to the outside, what we can take the fourth root of. So what is the 4th root of 16? 2, so he can come out as a 2. When I divide a to the 24th by 4, what does that come? A to the 6th. And when I divide b to the 12th by 4, I get b to the, what do I leave on the inside? A b. And so there's your answer. So that way I take everything out at the same time. Y'all still with me? Okay, so step 1. I call this my break it down, bring it down step. Does that make sense? If it's perfect, I just drop it down. Like if something's perfect, imagine it being up here on a pedestal. Would you want to break it apart if it's perfect? If something is absolutely perfect, don't break it. Okay? Don't mess with it if it ain't broken. So just drop it down. So that's what I did. The 16 was perfect. He's beautiful. Dropped him down. The a to the 24th. It's perfect. Drop him down. But b to the 13th was not perfect. That's not divisible by 4. So I had to break it apart. Now, if you have b to the 13th, you can't just like magically make it a b to the 12th. You can't just make a 13 to 12. That don't work. You got to do, you got to have another piece to it. B to the 12th, what would be left over to give you 13? A b. So that's what I broke it into. And then the next step, I circled the things that were perfect and I took them to the outside. And then I left what was not perfect underneath. Someone said earlier, they said, Miss Corns, what if I had the 4th root? Let's say that's a b to the 11th. b to the 11th is not perfect. What would you break b to the 11th down into? What's the largest number that can be divided by 4 that's close to 11? 8. So, and how many is left over? 3. Everybody agree? B to the 8th times b to the 3rd would be b to the 11th. And then I could, this would be a 4th root, divide this by 4. And so what would I have on the outside? B squared. What would I have on the inside? B cubed. And so something like that. Any questions? Yes, thank you very much. That's like the number 1 mistake. We're so used to writing square roots that we forget. Yeah, if it's 4th root, you got to keep it 4th root. I didn't go from 12. That was a different problem. This was part of the first problem. This was b to the 11th. And so what's the largest number close to 11 that I could divide by 4? B to the 8th, which that's why I chose b to the 8th. And so, but you can't just make an 11 and 8. You got to do something times something. So if I broke it apart and put a b to the 8th here, what would be left to get to 11? You need a b to the 3rd. So then I took the b to the 8th out and made that b squared times the 4th root of b cubed. All right, let's look at another one. These will get better and better. There's 12 examples total, just in case you're counting. All right, so let's look at each piece. Let's start with the cube root of 27. Is the cube root of 27 perfect? Yes. So if it's perfect, what do I do with it for right now? Just bring it down. Don't break it. If it's perfect, just drop it down. Okay? How about y to the 12th? Is it perfect? Is it divisible by 3? Yes, so I'm just going to drop him down. How about z to the 7th? Is it divisible by 3? No. So tell me, what's the largest number divisible by 3 that's close to 7? Z to the 6th. What would be left over? Z to the 6 times what? Z. So now, let's circle what's perfect. And I encourage you to circle what's perfect, because if you don't circle and you don't underline, what's going to happen, like especially when it gets really big? You're going to lose pieces and parts. Okay? So, what is the cube root of 27? 3. What's the cube root of y to the 12th? Everybody okay with that? Divide by 3. So y to the fourth. What is the cube root of z to the sixth? Z squared. What's left underneath? A z. So the answer would be 3 y to the fourth z squared times the square root of z. I did it again. Cube root. Cube root of z. Number one mistake. All right. So, what am I going to do with that negative 3 first? Bring it down, because he's on the outside. So just bring him down. What if I take a number to the outside? What will I do with the negative 3? I'll multiply them. Okay, so, but I'm just going to leave the negative 3 on the outside for right now. Is 12 a perfect square root? What's the square root of 12? Is it perfect? Nah, it's a decimal. So what do we need to do with 12? We need to break it apart. We got to do our factor tree. So what times what is 12? 6 times 2. 2's done. Then 6 becomes 2 times 3. What am I circling this time? Groups of 2. Okay, because it's a square root. Groups of 2. What if it was a cube root? Groups 3. What if it was a fourth root? Groups of 4. You follow me? All right. So I'm going to have a 2 times a 2 times a 3. Okay, how about c to the 6? Is it perfect? Can it divide by 2? Why by 2? Because this is a square root, right? So he's fine. Just bring him down. How about d to the third? Let's break him down into d squared times d. All right. So how many groups of 2 can I circle? So I have one pair of 2s. Now my question is, does that come out as 2 2s or 1 2? Do I need another 2? Just one pair. So you bring 1 2 to the outside. What do I do with the 2 and the negative 3? Multiply. So I'm going to have a negative 6. What else is perfect? C to the 6th comes out as a C to the third because I'm dividing by 2. D squared comes out as a D because 2 by 2 is equal to 1. 2 divided by 2 is 1. What's left on the inside? What else? A 3 and a D. Do you see how when I circle, it's really easy to see what's left. There's a 3 and a D. If you don't circle and you don't underline, I have a feeling you're going to miss a piece or a part. And it'll throw your whole answer off. Okay? All right, 2 more. I'm going to let you try these on your own. So I'll get you started on this. Is 640 a perfect 6th root? Put in 6, math, 5, and put 640. I hear no. So what are you going to have to do with 640? You're going to have to do a factor tree. And everybody says, I don't even know where to start. You can start anywhere. What are some things that you know goes into 640? 64, 10, because it ends in 0. What else? What else if it ends in 0? 5, 2, because it's even. You can start wherever you want to. Divide it by something that'll go into it. Break it down. My question is, what will you be circling? Groups of what? Why 6? Because it's a 6th root. Very good. regardless of the way you broke it down, you should have ended up with 7 2s and a 5. 2 times 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 5. How can you check to make sure that your factor tree is correct? Like if I multiplied 2 times 2 times 2 times 2 times 2 times 2 times 5, what should it equal out to be? It should equal 640. Do you see what I'm saying? Like, make sure that you get it working correct. Do you know what a lot of people break 8 down into? Do you know what, like, the number one mistake is? Instead of 4 times 2 for 8, you know what they do? 4 and 4, because they split it in half. Does that make sense? And 4 times 4 is not 8. Or they'll do 6, and instead of 2 times 3, they'll do 3 and 3. So I do highly recommend that you multiply your factor tree out, because if you do your factor tree wrong, what's the rest of your problem? Wrong. Okay? So here's where I am going to start to maybe do a shortcut. Anybody ready for a shortcut? Just like, so that you don't have to write 2 times 2 times 2 times 2 times 2 times 2 times 5. So my question is, we need a group of what? 6. So I see 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So how many 2's is going to come out from that set? 1, 2. Well, I've got this 2 right here, and I'm going to take another 2 with it. So what's going to be on the outside? A 4 on the outside. What number is going to be, what's left on the inside? A 2 and a 5. What do I do with the 2 and the 5? So what will I have on the inside? 10. Do you see how I just did my factor tree and put my numbers where they're supposed to go? Now, if that's too much for you, then I encourage you to write 2 times 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 5 and circle your group of 6. Does everybody understand why I need a group of 6? Everybody get that? This kind of reminds me of phase 10. Anybody ever play phase 10? You like on one phase, they'll say like, you need a group of 3s, you know, a set of 3s. And so you need 3 in a set. But then on the very next phase, they'll say you need a set of 4. So you got to get 4 of them. Like, it's not always going to be this pairs. If it's a square root, it's groups of 2. If it's a cube root, it's groups of 3. If it's a fourth root, it's groups of 4. This is a 6th root, so I needed a group of 6. 1, 2, 3, 4, 5, 6 2's. Okay, and then I have these 2 left over. So, how about x to the 14th? Is it perfect? Is it divisible by 6? No, so we got to break it apart. What's the highest number that can divide by 6 that's close to 14? X to the 12th, what would be left over? X squared. How about y to the 18th? Is it perfect? Yeah, that one's divisible. So he comes down. How about z? Yeah, you can't do anything with z. You can't break it down. It's not perfect. You're just going to have to leave z where he is. Yep.
What about the other 2 other sets of 2?
What other sets of 2's? I brought all of these out. And that was 1, 2. That was the 2 in red right here. All of these right here make that 1, 2. That is one set. One giant circle.
So we can take that set of 6
and make it 1, 2. For each set, you take one of the numbers out. Does that make sense? Like if I'm circling groups of 3, if I have 2 groups of 3, like a group of 3's and a group of 2's, you can take a 3 out and you can take a 2 out. You can take 1 for each thing you circle. Okay? All right, so I'm going to circle the x to the 12th. When it comes out, it becomes the x to the square because I'm dividing by what? 6. And then I'm going to take y to the 18th out, and it's going to become y to the 3rd. What's left underneath? 10x squared z. How many were able to get there? How many almost were able to get there, but you figured out where you went wrong? How many are lost? Anybody lost or kind of lost? Because it's the root. This number right here tells you how many you need in a group. So because it's the sixth root, I need 6 in a group. Does that make sense? All right, let's try one more. Okay, let's try one more and see where you get. So this time, what will I be circling? Groups of what? 5. This time I want groups of 5. 8 things. So 486 breaks down. Help me out. I hear 81 and 6. Am I doing anything different? 2718, 54 and 9. Any of those will work. It's fine. Say it again. 2 and 242. Yep, that works. Okay. It still works. Everything works. As long as it multiplies to be 486. So this will be 3 and 3. This will be 3 and 3. And here's the thing. Okay. First of all, this is a -1. So I'm going to have a -1 on the outside. I need a group of 5. So 1, 2, 3, 4, 5 threes. So how many 3s go to the outside? 1 3. And I'm going to times it with a -1. Don't forget, what else do I have left? A 2. So I'm going to have the 5th root of a 2. 8 to the 10th, is it perfect? Yes, so just bring him down. What about b to the 12th? Break it down. What's the highest? B to the 10th times b squared. So I can take this out and this out. So this will be a -3. A to the what? Why not 5th? Because I'm dividing by 5. And then b squared times the 5th root of what? 2b squared. How many were able to get there? Yes. How many almost there? How many knows where they went wrong? Okay.